Okay, I'm going to do some examples from sections 10.1 and 10.2, which is the beginning of the next chapter about radical expressions and radical equations. And I'm going to have to do this creatively. Okay, what you're seeing here is my desktop, because I couldn't upload the file, but Chapter 10 is about basically what we're going to cover. We're going to cover radicals, okay? And we're going to start with just radical expressions. And we start with the beginning, and we've talked about squares before when we talked about difference of squares. Like if I wanted to find the difference of squares, remember it was a binomial like x squared minus 25. And we always had a positive and a negative. That's because every positive number has two square roots. One could be positive and one could be negative. So to be a square root means that if you take that number and you square it, you get the original number that it is the square root of. Okay? Now there's two different square roots. One's positive and one is negative. We use the symbol, the square root of a, to represent what we call the principal square root. And then if we wanted the negative of it, we have the negative square root of a. So let me go back to the board and give you an example. Suppose I ask you to find the square roots of each of the following. Well, if I ask you to find the square roots of, say, 36, that would be 6 and negative 6. And that's true because when I square each of those, 6 squared is 36, and negative 6 when I square it is 36. Okay? So another example, if I ask you to find the square roots of, say, 100. Notice roots is plural. That means there's two of them. So that would be 10 and negative 10. And that's because 10 squared equals 100. And negative 10 squared equals 100. But, on the other hand, if I use this symbol, what we call a radical symbol, or some of you might call it the square root symbol, if I just ask for the square root of 36, that's called the principal square root. We only want positive 6. That would be the only answer to that. If I ask for the negative square root of 36, then that would be the negative 6. Okay? Likewise, if I ask for the square root of 100, that symbol alone means the positive square root, and then we put a negative in front of it, and that's asking for the negative square root. So every number always has two square roots. The square root symbol means the positive square root, and if you put a negative in front of it, that's asking for the negative square root. Okay? Let's go back to the presentation. All right. So that's the difference. You have to have a negative in front of it in front of the symbol to indicate the negative square root. All right. Now, some of these are similar to what we just did. The square root of 49 would be 7. Okay. And I should probably write these on the board. I'll go ahead and do that. I got several of these. If I want to find each square root, I'm going to go back. So let's do another screen here. The square root of 49 is the positive square root of 49, so that'd be positive 7. Now, sometimes you'll run into square roots of fractions, 25 over 16. Well, what that really means is we're just going to take the square root separately. The square root of 25 divided by the square root of 16. Well, the square root of 25 is 5, because 5 times 5 is 25, and the square root of 16 is 4. And once you take the square root, you simply drop the square root symbol. Okay? All right, now likewise, we were talking about negative square root of 4. And so it's going to be negative, and the square root of 4 is 2. And then let's do one more. Let's do the square root of 9x to the second. And remember, if you go back and think about what we've talked about with squares, 9x squared, and if you've heard me ask it, is the square of what? Well, 9 is the square of 3, and x squared is the square of x. Okay? And you can even extend that, like if I ask what's the square root of 64x to the 10th? What is 64 the square of? It's 8, because 8 times 8 is 64. And x to the 10th is the square of x to the 5th. Okay? Alright. So that covers, you know, just the basic definition of what it means to be a square root and what the symbols mean. Okay, now, you're going to be asked to use your calculator to approximate square roots, because the square root of 5 is not a whole number. There's no whole number that I multiply by itself to get 5. So in that case, you're going to want to use a calculator, and let's see if I can't bring one up here. I'm going to use the graphing calculator. Let's see if I can share that with you. Make sure I'm seeing that. All of the standard scientific calculators have a, I think you should be seeing that now, so make sure. I'm going to X out and then come back in. There we go. Okay. All of the standard scientific calculators have a square root button on them, and usually they're above the square. And if you see where my cursor is, you can see the blue square root button. Now, some calculators even have one that has another little number in the corner, and that's what we call the index. But if you're only looking for square root, you have to use the one that either has a 2 in the corner or doesn't have anything in the corner at all. So if I want to do the square root of 5 for this one, to get to that, I have to do second, and then my square root button, and then 5. And then we're just going to round it to whatever decimal places they want. So 2.236 sounds pretty good to me. So the square root of 5 we would approximate, and we use the little squiggly lines to approximate. It's not exactly equal, but it was 2.236. Okay, so you need to get comfortable using your calculator finding square roots. Alright, returning to where we were. Okay. Now, we're also going to talk about other roots like cube roots. Cube root, if you notice, it has a little 3 in the corner up here. That's called the index. It's like in the little check mark area in the corner. And it means the same thing, but cube root means to the 3rd power. So if something's a cube of something, that means you multiply it 3 times. Like, for example, 2 to the 3rd power is 8, so that means the cube root of 8 would be 2. Okay, so let me do a couple of examples of cube roots. Let's go back to the whiteboard. And I'll give you that example that I was just talking about just a minute ago. The cube root of 8, there's a big 3, is 2, and that's true because 2 to the 3rd power is 8. And you can check that by doing 2 times 2 times 2. And many of you might have a cube root button on your calculator. Alright, let's just do a couple more cube roots. The cube root of 27 is 3. And once again, that's true because 3 to the 3rd power, 3 times 3 is 9, times another 3 is 27. The cube root of a negative number, like negative 125, can be negative. That would be negative 5, because if you do negative 5 times negative 5 times negative 5, that's 3 of them times negative 5, you do in fact get a negative, so it's negative 125. And then if you put all that together, and say you wanted the cube root of negative 8x to the third, well, the cube root of negative 8 is negative 2, because 2 times 2 times 2 is 8. It's going to be negative. And the cube root of x to the third is x, because there's 3 x's. Okay? Now, I might just make a little list right here of squares and cubes. So let's do that. Let's do some squares. And then let's come over here and list cubes. Okay, and I will make a reference to them. You probably know most of the squares already. Like, for example, well, 1 is a square of 1. 4 is a square of 2. 9 is a square of 3. 16, 25, 36, 49, 64, 81, 100, 121, I'm just going to list several of them, 144, 169, 196, and 225. That's the first 15 squares. Like I said, if I go down the list, 1 squared is 1, 2 squared is 4, 3 squared, 4 squared, 5 squared, 6 squared, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. Now, cubes are not recognized quite as often. So, well, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, and 7 cubed is 343. And as you notice, they get kind of big kind of fast. So we're just going to list the first 7 cubes. Okay, so you might want to just kind of recognize those, be able to recognize those, not necessarily memorize them, but if you see one and you think, okay, I think that's 3 to the third power, or I think that's 16 squared, or something like that. Okay, all right. Now, we can also take higher roots. Oops, I don't want to move that down. We did some cube roots. We can also do any root. We can do 4th roots, 5th roots, 6th root, as long as when you raise that number to that power, you get that answer. Okay, so we're going to do several of these. I'm going to come back to those. Let's go back. Let's do, for example, the 6th root of 64. So basically we're looking for, that means what number raised to the 6th power equals 64. And the correct answer is 2. So 2, if you multiply 2 6 times, you're going to get 64. 2 times 2 times 2 times 2 times 2 times 2 does in fact equal 64. And some of these you might kind of have to guesstimate at if you're not real comfortable with it. The 5th root of negative 32 is actually, once again, what that means is some number to the 5th power is negative 32. That's what that means. And the answer there is negative 2. And most of these are going to be 2's. And I'm going to show you this one, the 4th root of negative 16. Now this one means some number raised to the 4th power is negative 16. This has no answer. This doesn't exist. And the reason it doesn't exist, well, I should rephrase that. I should say it doesn't have a real answer. Let me change that. Doesn't have a real answer. And the reason for that is you can't take any number and multiply it 4 times and get a negative, because 4 is even. No number to an even power will equal a negative. An even power is always going to imply that the answer is positive. So this doesn't have a real answer. Now, it's okay if the power is odd. Odd can be either positive or negative, okay, depending on how many negatives you have. But even means they're all the same sign. It's going to end up being positive no matter what. Okay, so that's pretty much everything there is to know about 10.1. Now let's talk a little bit about 10.2. 10.2 takes it just a little bit further into what we call rational exponents. And remember, we just finished studying rationals, which means they're fractions. So we're talking about exponents that are fractions. And the beginning here says, so far we've only worked with integer exponents, but now we're going to extend our exponents to fractions. And this is the general rule, and then there's another rule that kind of adds to it a little bit. A fractional exponent is really the same as a radical, okay? So I'm going to go back and, well, you know what, we can write, let me take these and I'll show you how to interpret them. Let me jot these down. I was hoping I could actually write on these, but I can't. So I have to go back to the little whiteboard. When you're dealing with radicals and fractional exponents, let's go back. When I have 81 to the 1/4 power, when you have a fractional exponent, the denominator tells the root index. So that really means the 4th root of 81, and the 1 is actually the actual exponent. 81 to the 1st power, which is just 81. So we don't really need that 1. So we could really get rid of that. Okay? And it's just another way of writing the 4th root of 81. It's 81 to the 1/4 power, which would be 3, because 3 to the 4th power is 81. All right, now the other example I had was 64 to the 1/3 power. Once again, the bottom number is the root index, so we're actually now looking at the cube root of 64 to the 1st power, which is 64. And these mean the same thing. These are equal. And the cube root of 64 is 4, because 4 times 4 times 4 is 64. All right, let's do one more. X to the 1/4. Now this one we can't really find the answer. Let me go back. The 4th root of 81 is 3. I'm going to write that out. 3 to the 4th is 81. And in this one, 4 to the 3rd was 64. So that's how I got that answer. Now when we're dealing with x to the 1/4, I can't really find an answer, but I can write it as a root. So once again, this is the root index. So this is the 4th root of x to the 1st power, which is x. And that's what that means. It's just another way of writing radicals. Rational exponents are just another way of writing roots for radicals without the radical symbol. Okay? All right. Returning to our little presentation. We just did those. Let's see. Okay, now, this one says use radical notation to rewrite, simplify if possible. Let's look at a couple of these. Negative 16 to the 1/2, 32 x to the 10th to the 1/5, 16x to the 7th to the 1/3. Okay, now we're pretty much just going to write it. If we can't, well, let's go ahead and go do it, and then I'll show you. All right, so let's take the first one. The first one was negative 16 to the 1/2. And there was no parentheses around the 16. Let me just double check. Yeah, there was no parentheses, so the negative doesn't go with the square root, with the exponent. So this tells us that we're doing the square root. And with square root, you can put a 2 here, but it's understood to be there if it's not there. And so we usually leave it off. And then we've got 16 to the first power. Now the negative goes outside. The only time it would go on the inside is if this had been in parentheses. Like if I put this in parentheses like this first, then it would go on the inside. But it wasn't like that, so the negative is not part of that radical. So that answer, I can actually simplify that because the negative is on the outside and the square root of 16 is 4. Okay? Alright, let's see, the next one was 32 x to the 10th to the 1/5. Okay, now this one is in parentheses, okay? So the 5 in the denominator of that fractional exponent tells me I'm taking the 5th root, and then all of this is going to be on the inside to the first power. That's what the 1 means, but anything to the first power is itself. So 32 x to the 10th. And the 5th root of 32 is 2, because 2 to the 5th power is 32. And the 5th root of x to the 10th is x squared. Because if I have 5 of those, then I'm going to make 32x to the 10th. Alright? Okay, let's do this last one. 16x to the 7th to the 1/3 power. Okay? So the 3 and the 1/3 power tells that I'm taking the cube root, and then all of this is going to be on the inside because it's in parentheses. And I can't really, well, we haven't learned how to simplify that yet. We will learn how to simplify that. But 16 is not a cube, and neither is x to the 7th, so we're going to leave it like that for now. Okay? So those are some examples of how we can take it from exponential form and change it to a radical so we can simplify it. Oops. Lost my place. Okay, let's try this again. Okay, we've already passed all that. So let's see here. Okay, so in general, we can generalize this. Sometimes the numerator is not a 1. Okay, and I'm going to do some examples of this form right here. If you have a numerator other than 1, we're going like these here. Instead of being 1/2 power or 1/3 power, we're looking at -4 to the 3/2 power or -8 to the 4/3 power. Okay, so let's do those. New screen. All right, here's what that means. Let's start off with the -4 to the 3/2 power. Okay, now, first thing you should note is that that negative is not in parentheses, so it doesn't go with the exponent. So the 2 tells us the root, so that's the square root. The negative's on the outside because it's not in parentheses. And then you could do one of two things. You could do 4 to the 3rd on the inside, or you could do this. You could do negative square root of 4 to the 3rd power on the outside. I prefer the second way. See, the top number, this 3, is actually the exponent. The bottom number, that's your exponent, the whole exponent. The bottom number is your root. So you can put the exponent on the inside of the root or the outside. I like it on the outside of the root, and the reason for that is the square root of 4, we all know, is 2. And then I can raise it to the 3rd power, so that's going to end up being -8. If you put it on the inside, it's not necessarily, there's nothing wrong with it, but you're going to make it bigger first before you take the radical, which makes it smaller. So that would be 4 to the third is 64. Take the square root, and that's also going to be -8. So they're the same answer. But I think if you take the radical first, it makes the number smaller and just a little bit easier to deal with. Okay? So let me show you the other one. The other one was -8 to the 4/3 power. So I'm going to show you once again. The 3 is the root. The negative's on the outside. So we're looking at the cube root of 8. And then you can either put, and let me show you the difference. Watch this. I'm going to put the 4th power on the inside first. That's one way you could do it. But that means you have to do 8 to the 4th power first, and then take the cube root. I don't even know what 8 to the 4th power is. The other way to do it is to put it on the outside like this, and take the cube root first, which I think is easier. Because we just talked about what the cube root of 8 is. The cube root of 8 is 2, because 2 to the 3rd power is 8. And then we raise it to the 4th power. It's a little bit more manageable, and that would be 16. Okay? Alright, now let's see where we are. And remember, negative exponents, let's do one of these. 64 to the -2/3. Now you've learned about negative exponents in the past. So let's do one with the negative exponent. 64 to the -2/3. Now, the negative, what it tells is that the 64 goes in the denominator. The negative makes the base of the exponent flip. So first of all, that is the same as 1 over 64 to the 2/3, because the negative exponent, the definition of negative exponent is a base to a negative exponent is equal to 1 over the base with the positive exponent. So all I'm doing is flipping. I'm taking the reciprocal. Negative exponents really means reciprocals. Now we'll apply what we just talked about. This is the cube root. So that's the cube root of 64. And then, like I said, I like to put the actual whole exponent on the outside. Okay? So I'll do the cube root of 64 first. The cube root of 64 is 4. That's one of those ones that I gave you in the list. And then we square it and we get 16. So 1/16 would be your answer. Okay, now, presentation keeps fell off for some reason. Okay, now, the properties, since these are rational exponents, the properties of exponents, we do the same thing. So I'm going to show you these properties that you learned back in Math 98. You add the exponents when you're multiplying, you multiply the exponents when you're raising a power to a power, and you subtract when you're dividing. All those that you learned in the previous course. So I'm going to do these examples here and show you how we can apply them. Okay, so we have, let me write them down so I can go back to the whiteboard. And actually, I think I may alter the last one. I think I'm going to change the last one. Okay, so I can show you some of each property. All right, so let's simplify using the properties of exponents. That's what we're going to do. Okay. All right, so let's start off with the first one. X to the 1/2 times x to the 1/3. Now, remember, going back to what you learned, I'm just going to do this off to the side, and then I'm going to erase it. Suppose that were just x squared times x to the 3rd. You should add the exponents. Okay? All right, so in this case, you may want to write it out first, 1/2 plus 1/3 And you can either do that on your calculator, or you can go ahead and find a common denominator, which we should be really good at right now. The common denominator is 6. So to make 2 into 6, we'd have to multiply by 3 over 3, which gives me 3 6. To make 3 into 6, we'd have to multiply by 2 over 2, which gives me plus 2 6. So in simplest form, that would be x to the 5 6. Okay? And that's all you can do, because you don't know the value of x. All right? Now the other example was 7 to the 1/3 over 7 to the 4/3. Now the property for this is when you divide, you subtract the exponents. So I'm going to write it out. That's 7 to the 1/3 subtract 4/3, and this one already has the common denominator. 1 minus 4, that would be 7 to the negative 3/3, or just 7 to the negative 1. Now, and remember, they may ask you to write with positive exponents, and so that means 1 over 7 to the first power. All right, let's do one more example using another property. Suppose I have x to the 2/3 to the 3/5 power. Now in this case, when you raise a power to a power, you should multiply the exponent. So we're really going to do 2/3 times 3/5. And we should be really good now, since we just finished a chapter on rational exponents, we should know to cancel those. And so in simplest form, that would be x to the 2/5 power.